For decades, software developers have been stuck with this really frustrating choice. Do you build something that's super fast, or do you build something that's safe and reliable? It always felt like you couldn't have both. But what if a language came along that could finally deliver on that promise? Well, that's what we're talking about today. We're going to dive into the story of Rust and its mission to build a safer, faster future for pretty much all the software we use.
So to really get why Rust is such a big deal, you first have to understand the core problem it was designed to fix. It's this fundamental dilemma that's been hanging over programming for, more than half a century.
Yeah, that dilemma, it pretty much boils down to this one question. Do you want your code to be blazing fast, squeezing every last drop of performance out of the computer? Or do you want it to be safe and reliable so it doesn't crash and protects you from these really nasty, hard-to-find bugs? For a long time, the answer was just, you got to pick one.
And this basically split the programming world in two. So on one side, you've got languages like C and C++. These things are unbelievably fast. Why? Because they let developers manually control every little piece of the computer's memory. But that's a double-edged sword, right? One tiny mistake and you can create these catastrophic bugs and massive security holes. Then, on the other side, you have languages like Java and Python. Their big thing is safety. They use something called a garbage collector, which is basically an automatic process that cleans up memory for you. It's way, way safer, but having that process running in the background all the time adds overhead, and that means you take a hit on performance.
Okay, so this is where Rust enters the picture. It was created with one specific goal in mind, to completely shatter that trade-off. The whole idea was to give developers the raw speed of C++ and the memory safety of a language like Java, but without any of the compromises.
And you can see this mission just baked right into its official tagline. Look at those two words, reliable and efficient. That's not an accident at all. That is the core promise of Rust, delivering both safety and speed to empower everyone who builds software.
So how does it actually pull this off? What's the magic trick? Well, the secret sauce is this thing called the borrow checker. The best way to think about it is like a super strict librarian for your computer's memory. It has a very clear set of rules about who can use a piece of data and for how long. But the real magic is when it does this. It checks all these rules while you're still writing the code, before your program is even built. We call this compile time checking. And what it means is that a whole category of nasty memory bugs get caught and fixed before they can ever cause a crash.
But a language this revolutionary didn't just appear out of some corporate boardroom. Nope. Its origin story actually starts with a very human and, honestly, a very relatable moment of frustration.
And believe it or not, it all started with a broken elevator. Seriously. Its creator, a developer at Mozilla named Graydon Hoare, was just completely fed up with the glitchy, crashing software in his apartment building's elevator. And that real-world experience with unreliable code is what inspired him to start a personal project, to try and create a language where those kinds of failures would be, well, almost impossible.
And let me tell you, that personal project grew incredibly fast. What started in 2006 caught the eye of Mozilla by 2009 because they saw its potential. The huge milestone, though, was 2015. That's when Rust 1.0 was released, which was a promise to all developers that the language was stable and ready for the real world. And then, in 2021, the biggest names in tech, we're talking AWS, Google, Microsoft, they all came together to form the Rust Foundation, basically cementing its place as a pillar of the entire software industry.
So what is it that makes Rust so compelling to all these companies and to so many developers? Well, it really comes down to three core strengths, or what we can think of as the three pillars of Rust.
First up, performance. Just unparalleled performance. Remember that garbage collector we talked about from other languages, the one that runs in the background? Well, Rust doesn't have one at all. And that means there's no extra overhead, making its code incredibly fast and super memory efficient. This is just perfect for the really demanding stuff. Think web services, game engines, or even tiny little embedded devices. Some studies even show it's more energy efficient, which is a massive bonus for data centers.
The second pillar is just ironclad reliability. And this all goes back to that borrow checker we mentioned. Its ownership model is so powerful that it literally makes it impossible to write entire categories of common bugs, things like null pointer errors or data races, the stuff that gives developers nightmares. The compiler basically becomes your partner in coding, forcing you to write safer, more correct code right from the start.
And finally, pillar number 3,
Productivity. Now, Rust isn't just a powerful language. People actually say it's a joy to use. For one, the compiler gives these famously helpful error messages that often tell you exactly how to fix your code. It's also supported by some of the best documentation out there and has a fantastic tool called Cargo that makes building your project and managing all its parts an absolute breeze.
So, when you have those three pillars, performance, reliability, and productivity, it's really no surprise that Rust's adoption has been, well, nothing short of explosive. This isn't just some language for hobbyists anymore, it's being used to build some of the most critical software infrastructure on the entire planet.
And I mean, this isn't just theory. Just look at who's betting on Rust. For the first time ever, a language other than C is being used right inside the core of the Linux kernel. That's huge. Microsoft is rewriting fundamental parts of Windows in Rust to get rid of security bugs. Google's using it in Android. Amazon relies on it for critical services at AWS. And companies like Discord have seen massive performance boosts by rewriting their systems with it. This is a seismic shift in the industry for real.
And if you want some hard data, just look at this number. Over 108,000 stars on GitHub. Now that is a massive signal from the developer community. It's more than just a number, you know? Each one of those stars is basically a vote of confidence, a sign of approval from the very people who are building software day in and day out. It just shows an incredible level of passion and excitement for what Rust is all about.
But honestly, if you need just one statistic to really understand Rust's impact, this is it. For an entire decade, Rust has been voted the most admired programming language in the annual Stack Overflow survey, which is the biggest of its kind. And admired here means that the developers who actually use Rust absolutely love it and want to keep using it more than any other group of developers. A winning streak like that is it's unprecedented. It speaks volumes.
So with all this incredible momentum, you gotta ask, right? What does all this mean for the future of software?
Well, get this. The push for safer software is no longer just some technical debate among programmers. It's now being talked about as a national security issue. In 2024, the U.S. White House actually urged the tech industry to move to memory-safe languages to help protect the country's cybersecurity. And guess what? The report specifically called out Rust as a leading solution. That's a huge signal that the ideas Rust was built on are now seen as vital for our entire digital world.
And really, that brings us to the biggest question of all. For so long, we've just accepted this world of trade-offs. We built systems that were either fast or they were safe, but almost never both. Rust is proving that we don't have to choose anymore. So the real question it leaves us with is, now that those old constraints are starting to disappear, what new, bigger, more ambitious problems can we finally dare to solve?